So again, welcome back, ladies and gentlemen. This lesson is now on the example 3, 4, and 5, typically. And I would say this is kind of not the hardest part, but again, it's just awkwardness of what you're learning in grade 11. It's called function notation. So what you see right now on the chalkboard is f bracket x bracket. Unfortunately, you have to get used to saying this properly. This is known as f of x or f at x. And even though when we write like that, some students say, I don't get what that means. So that's the definition of how you say it to someone. You don't say f times x, it's just f of x or f at x. Here is how I try to connect to my students when they see it first time in grade 11. X comma y, notice again, ordered pair, independent, dependent, input, output, and that's actually probably the best way. Input, output, domain and range. There's a reason why I put input and output like that, because this is going to help us. In grade 11, notice how we write it? X comma, and notice I'm doing this for emphasis, f of x. So in short, I know it seems weird, this is really y. This is y. Let me give you an example specifically with equations. Notice we haven't really talked about equations or the domain and range, but I think you guys will understand it with an example. We're not going to do example 3 just yet. I want to give you this one. So y equals 2x plus 1. Well, somebody say, what do I do that? I agree. In grade 9 and grade 10, this is how we would word this kind of question. Solve for y when x is 4. And what would you do? I think a lot of you conceptually you know you do. Well, Mr. Chen is saying when x is 4, we're going to replace that x with 4 and continue this question. Really easy. 8 plus 1 is 9. Notice what you would do normally. You understand that this is 4 comma 9. Before we continue, everyone okay? This is in grade 9. So what is the question like in grade 11? It's almost the same, but a little bit condensed. So it's just a formality, a way to communicate to the reader how to solve things. Normally it's going to be written like this. F at x equals 2x plus 1. And then watch what we're going to do. F at 4. This is really saying solve for when x is 4. Before we continue, everyone okay? But notice it's not going to be the same thing. So that's why a lot of you understand what we're doing. Whatever value is here, which is the x value, it gets inputted into the rule or formula or production line, right? It's like thinking of working into a factory. Whatever you put raw materials inside, and it outputs the product that you want, right? There's a famous, well, I don't know, again, I'm dating myself, maybe some of you are not avid video gamers. There's a video game called Factorio, where you actually have to kind of make things your own simple machines on the computer. And it's very Zen-like and fun and everything. I don't mean to promote it, but that's the idea. You input 4 and output 9. And that is why inputs and outputs. Before we continue, everyone okay? This is my example. I like doing this simple one because linear equations are pretty easy. A lot of you actually understand this when I write it like this. So let's just pause for a second if you need to take a look at that. And again, if you're at home, feel free to pause the video or zoom in. Hope it makes sense. I'm going to erase that other part of the chalkboard. And now we're actually going to take a look at example 3. And hopefully everyone can follow along. And notice this is now the math portion. Let's pause here for the class. Any questions right now before we keep on going? So example 3 is as follows. And again, I do recommend for a lot of you might want to try to save the question. This is f at x equals 3x squared minus x minus 6. And notice for the very first part, again, it's not saying f times 2, that is not what it says. In English, this means f at 2 or f of 2. Basically, one more time, when you input 2 into the function, what is its output? So notice, this is now the algebra stuff that you have to be practicing. And that is why I had to review grade 10 math with you. Order of operations, exponent rules, etc., fractions. Some of you, unfortunately, still make the mistake. You'll put 6, but a lot of you realize dead math means do the brackets first. So 2 squared is 4. 4 times 3, that's 12. Minus 2, minus 6. 10 minus 6 is 4. That is the output for this question. Make sense? Let's see if someone actually can do question 2. Take your time. Take a moment. I'll have everyone out though. F at -1. Any volunteer want to try to share with the class their answer for example 3, part 2? Sam?
-2.
-2? Incorrect, I think. Oh no, I'm right. I think you're right. Sorry, I'm wrong. Everyone okay with that? Any questions? We won't do part 3 if that's okay. I think everyone's okay with 0.5. It's a little bit tricky. So now we're going to go to example 4. And this one is the kicker. It seems kind of weird. And we'll do example 5 for some of them. Example 4 looks something like this. So, it's almost leading you what you're supposed to do. Not the best drawing, whatever. Say it with me. Got this wrong, but so notice it says in the example 4, evaluate a function by graphing. So from the graph, y equals f at x, as shown. So there you go. This is a function, blah, blah, blah. Determine f of y. In terms of Mr. Jen, there's nothing to input. But notice the 5 is our x cow value. So you just read out the graph, and it's actually telling you that this answer is 3. I don't know what the rule is. I don't know what the actual production value was, but that's how you read out the graph. So a lot of you actually understand that. Let's try question 2. Really easy. F at 2. Sorry, not F 2. F at 0. I already ruined it. F at 0. I just gave the answer. Anyone tell me the answer? Nora?
2.
It is 2. Because where 0 is here. 2. Let's do the last one. It takes longer for me to draw it than it is to actually answer these questions. That's why I think this is the power of actually graphing, which again, some students for some reason in grade 9 and grade 10, they hated it. I hate graphing. But it's actually easy if you can read off it. F at -4, and that's a 1 is correct. So those are the answers. Any questions? Notice if it asks you, well, what's f at -2? It's almost impossible. We could guess f at -2 is maybe a good approximation, but we just can't get a good output, right? But clearly you can say f at -2 is maybe not higher than 3, right? Because it doesn't look it. Or maybe it is. Sorry, I didn't draw mine very well. So it should actually be the higher, right? So that's my fault. They didn't know. So it's supposed to look something like that. So maybe not higher than 7, right? Like that'd be not a good guess. Any questions still before we keep on going for example 5? So the whole point what we're trying to do for this function notation before we get to example 5 is actually get you used to the operations of it. There's actually some interpretation that actually means something else. But as it stands right now, we don't really fully know it. We just have to get you used to the algebra. Can I erase the examples? Can I erase these examples before we get to example 5? So example 5, notice, wait a second, given f at x equals 2x minus 7, what's this? Oh, it's another function. G at x equals x squared plus x. So I'm just going to copy those equations out. F at x, 2x minus 7, and g at x equals x squared plus x. Oops, I went too fast. We'll just do a couple of these if that's okay. A and B. And then maybe we'll do question E. Not the extent of this function notation. I think a lot of you know what you need to do. So for the first example, it seems awkward, right? How would you read this? Well, f at c. Basically, one more time, what you're trying to do for this function notation, ladies and gentlemen, is input this value wherever you see x for the equation. Now notice, for some reason some students get confused. Do I also put in g? The answer is no, this is g at x. This is f at c. So we're only going to use this first equation. So for question A, notice what we're going to do. F at c is equal to 2 times c minus 7. And then some students say, okay, what do I do next, Mr. Chen? Well, that's it. That's the answer. 2c minus 7. We can't go any further. So notice, sometimes the inputs are not always numbers. Sometimes there are other variables, other symbols, even expressions. Let's take a look at question D. Question D says, f at x minus 2. So what are we going to do? Again, equation f at x is 2 times whatever that input is. In this case, it is x minus 2 minus 7. And this, I think a lot of you know what you're supposed to do. You tend to actually put them in standard form. So, we get 2x minus 4 minus 7, and then collect like terms. And this is as far as we go for this question. Before we continue, everyone okay? So notice the inputs can actually be other parts. Think of it like DLCs, maybe a lot of you understand this from video games or downloadable content, right? This is like an extra thing that you're inputting, right? With more skins or with more attachments, right? It doesn't change it. It just looks a little weird. The last one, I think a lot of you know what we have to do. For question E, if you read it, it's f at 3 plus g at 2. So for this question, we actually have to do them both separately. Right? That's what I recommend for a lot of you. So a lot of you are going to do f at 3, and then some of you are going to do g at 2, and then sub them in. You might want to wait for me, that's okay. 2 times 3 minus 7. Notice that's only for f, that function. What g at 2? That's g at equal to 2. But again, this function is x squared plus x. So 2 squared plus 2. Now again, I recommend that you go slower. I'm just trying to show you as a teaching tool what you're supposed to do. So I recommend you do this first, which I think I remember 6 minus 7 is negative 1. And then 2 squared, which is 4 plus 2. 4 plus 2 is 6. And then actually follow what this question is saying. F at 3 plus g at 2. So f at 3 plus g at 2. Hopefully this camera is getting me. Yeah, it is. What is f3? That's negative 1. This is a plus sign. And that's 6. Before we continue, everyone okay? Anyone not understand what I'm doing? I like going this slowly to show you that it's actually not that bad. And the answer for this question is 5. 5. So we can actually just go slowly. Okay. Any questions from the class at hand? I know I only did 3 examples. I did question A, D, and E. And then on page 3 and page 4, you should be okay. Except some of them are a little bit trickier. So if you have to ask me questions on Wednesday or Thursday, that's okay. This is in my opinion, it takes so long to do this very first introduction to functions. There's a lot of new concepts. So to recap really, really quickly, we looked at defining what functions and relations were for every x, there's one y, and how to organize it. We also looked at domain and range and inequalities, and this idea of where the boundaries are. And then the third and final part is actually what is function notation. And function notation is just simply a new way of actually writing what y is. What's the output, right? Given the input. Any questions from the class?